Thanks for coming, everyone. Welcome. So I'm David. I'm one of the members and founders of the Seattle Video Tech organization, along with Gabe over there, who's manning the camera. Let's see. Thank you to Memento. Thank you to Surf for hosting us and organizing everything. We've got some fantastic lineup today. Yongjun from Amazon is going to start us off. And then we're going to have Surav, who's going to talk about resiliency and origin. And then I think we're going to close off with Khwaja from Memento. And then I think, Johnny, what's the plan afterwards? We're heading somewhere?
Yeah, so we got the speakers, and then afterwards we're going to head over to the Diller room. It's a couple blocks that direction. I can walk you guys there and grab some drinks.
So we're going to a bar afterwards is the important thing to take away from that. So with that, one last thing. If you're not a member of Seattle Video Tech, find us on LinkedIn, talk to me or Gabe afterwards. We can let you know what the URL is. It's seattlevideo.org. It's not very difficult. We have a YouTube channel. We'll post these videos up on YouTube unless someone absolutely protests. Afterwards, we have an archive of previous content up there, which some people may find interesting. And with that, I will turn it over to you, Yongjun.
Yeah, thanks for the opportunity to talk here. This is Yongjun Wu, Senior Principal Engineer in Prime Video, working on video playback end-to-end, from camera to screen, including both live streaming and film demand, with and without ads. So today, my talk is about pattern template manifest for live streaming, already adopted by Dash standard. So we will go through what the problem is. Then I will explain why the problem exists in live streaming with some background. The third part is about where the problem comes from with some details through case studies. The fourth part is about the innovation of pattern template manifest adopted by standard recently. In the end, we'll talk about some extension and looking forward in the future. So what is the problem here? It is about the manifest size growing linearly as time duration increases for the overall manifest. It is a generic problem across Dash, HOS, and smooth streaming, agnostic to any streaming technologies. It is a common behavior exists in all kinds of packages, including Elementor Media package, Unified package, and the Hulu package in the past. So it is more significant, obviously, in live streaming because we refresh manifest every n seconds, such as 2 seconds or 4 seconds. So many scenarios are impacted by bigger manifest, such as just after broadcast, in a long duration, start over in live streaming, larger than 1 hour, or live manifest refresh with a live window. In the past, in Prime Video, we analyzed that CPU compute, bandwidth, and video delivery, memory storage, all impacted by the bigger manifest across a video streaming system on both service side and device side. So let's take a look on some Dash manifest sample. I got a couple of samples captured in the past from Elementor Media package and the Hulu. So here is one sample manifest I captured a couple years ago, used for as example or sample. We can see that the audio segment timeline has some pattern underneath. Similarly, a Hulu manifest we captured also have a certain pattern within the audio segment timeline. Let's come back to the talk. So from some analysis, we obviously see that manifest size will be n times larger when there are n-audio tracks and linearly grow, such as there are 4 tracks, 4 audio languages in Prime Video TNF, and 3 tracks in EPL in Prime Video. And even worse is that if there are multiple codecs, like AAC, DD+, or Atmos, the multiplication will be m times n times larger, linearly grow. Those samples are put on the GitHub for public access. So all the impacts are real. We see that on the product, really impacting the customer experience in different scenarios. Back in 2019, 2020, we had to dive deep, address the problem. So the second part is about why the problem exists. There's some background. So we know that when packages try to fragment, the fragmentation tries to align audio and video in the best effort. For example, in this case, in the figure, 264 at 30 frames per second, AAC at 48 kHz. 264 has a 2-second constant fragment duration, and AAC has a certain pattern, 2.005, 3 times, and 1.94 second. They try to align audio and video in the best effort with minimal misalignment, 0, 5.3, 10.6, and 16 milliseconds. So we also look into the misalignment, why the alignment between audio and video segments are necessary. That's because trimming a portion of the content from a long duration will be a lot easier because audio video segment will be misaligned in a minimal way. And then we know that some MCEME player will play the full audio video segment without dropping the audio video frame in the beginning or in the end. That's why it requires minimal misalignment under the AV sync threshold. That is minus 125 plus 45 milliseconds. And conceptually, playback seek will be a lot easier, just to jump to a certain video segment. Corresponding for audio is the same video segment number. And during our discussion, we also know that some media services, like Elemental Media Package, require the same number of audio video segments in live streaming scenario. And our own proprietary service, PseudoLive live streaming, also requires a perfect alignment between audio and video at a certain cycle. So overall, there are many different reasons to require audio-video alignment in different segments at the same segment number. And we also know that if audio and video are using the same constant segment duration, slightly different, it will introduce huge drift and never line at the same segment duration, at the same segment number. For example, if video segments are 2-second constant, audio segment is 1.94 constant, and then the drift will be linearly increased as n times 60 milliseconds at the same segment number for audio and video. So let's take a look where the problem comes from through some case study. There are 2 case studies. Case 1 is about integer frame rate, 30 frames per second, and audio sampling frequency for 80 kHz. Case 2 is about non-integer frame rate, 2997 frames per second, and AAC audio sampling frequency for 80 kHz. So how the alignment happens, here's the equation. X times 1 over 30 equal to Y times 1024 divided by 48,000. The second equation really has some interesting meaning. That means every 16 video frames and every 25 AAC audio frames can align perfectly with a duration of 0.53 seconds. So that means any integer multiplication of 0.53 seconds can have audio video align perfectly. That requires we set the IDR frame duration interval and the video segment duration carefully through configuration in the encoder. In the real world, we often set the video segment to be 2-second constant. Then we have a different equation, f times 2 equal to y times 1024 divided by 48,000. The second equation means every 4 video segment and every 375 AAC audio frames can have the same duration, 80 seconds. We don't use 80 seconds segment. That means 80 seconds have 4 segments of 2-second constant duration, and then a certain pattern, 2.0053, 3 times, 1.94 seconds of audio segments. They can align perfectly. And we know that this equation explains how Elemental Media Package and Unified Package generate the pattern. Similarly, we have a different case study for non-integer frame rate and audio sampling frequency for 80 kHz. Here's the equation. The second equation really means every 1920 audio video frames and every 3003 AAC audio frames can have the same duration, 64.064 seconds. So this magic number have 16 4.04 seconds of video segments, and 5 3.99 second, 11 4.001 second audio segments. That is a pattern, a cycle from the sample manifest from Hulu. So we go through all kinds of case studies through some program, and the general observation is that audio and video segments could be perfectly aligned in the integer frame rate and the most popular sampling frequency for audio, for the 80 kHz, 32 kHz, for different codecs, AAC, DD+, Atmos, through some careful configuration in the encoder. However, if we use a constant 2-second video segment duration, there must be a cycle for audio segment duration, even with integer frame rate. Same for non-integer frame rate. So we know that it's inevitable to have a pattern and a cycle of audio segment duration with non-integer frame rate and a sampling frequency, no matter what kind of audio sampling frequency we choose. So now we come to the innovation of pattern template manifest. We know that in Dash, long time ago, there's already some kind of run length compression. It's first order compression. That is ad hoc syntax. Specify the repeat count of the number of following contiguous segments with the same duration expressed by the value d. There are certain constraints specified in the second paragraph. It's more like a first order compression of the segment timeline. It works very well for video with constant fragment duration. So after we observe the audio segment timeline have some kind of cycle and pattern, it's very obvious. Back in 2020, 2019, we proposed some kind of proprietary technology named a pattern element, express a segment timeline pattern in 2 or more p elements. This duration pattern can be referred by the ID, of course, p element. So here's an example from the Dash standard 6th edition second draft in FDRS status. Here's a full example, so showing that there are a total of 165 segments specified by R equal to 164. The S element describes that a segment really enters the pattern from index 3. PE means enter point in the pattern. And the pattern has 12 segments in one duration and another segment in a different duration. This is the full example from the Dash standard. So we can see that it's more like a second order compression for audio segment timeline in a pattern compared to the first order run length compression in ADR. So now to make it complete, video constant duration can use a first order compression. Audio segment timeline with a pattern can use a second order compression. It is applicable for all different scenarios in prime video like a jab, start over, line manifest. To make manifest size stay constant, not independent of total overall duration. No matter how many hours you have, it's always constant. And optimize manifest generation, parsing, storage on both service and devices. Of course, the bandwidth for download, for CPU compute, storage, and internet bandwidth. So we have some sample, like a very simple sample, single audio AAC codec, one audio track, reduce manifest size for 2 hours from 121 kbytes to 24 kbytes. Some other example like EPL and others with multiple codec, it can be like 4 times more, 20 times reduction. We have seen that a couple megabytes of manifest size becomes 100K or even less constant. So here's some extension in the last topic. It is also applicable for other streaming technology because this is fundamentally coming from the audio-video compression property rather than the manifest itself. Now it's part of the standard, will be finalized in the official spec very soon. It is not part of HOS yet, so we need some kind of manifest proxy to unpack the pattern into a flat HOS manifest in order to make Apple Inbox Player work for the HOS manifest. But we still achieve most of the game, even with overhead of unpacking. We, Prime Video, deployed this technology since the end of 2019, early 2020, and with slightly different syntaxes, but the main idea is exactly the same. We have some slightly different naming and different format, but we achieved most of it in the past 6-7 years. So, of course, we can propose the same thing to HOS. It's similar to Dash, and get rid of the unpacking of the pattern manifest into flat manifest, make it a part of official HOS manifest spec. So we can see that after the application of second order compression, Dash manifest size will stay constant, independent of overall duration when the live streaming has one single period. So we do have lots of live streaming with burn-in ads. Then no matter how many hours, 24 hours, 48 hours, it's constant size manifest. And there's some limitation, of course. Pattern template manifest only compress audio segment timeline within a period with a second order compression. When there are lots of ads insertion with lots of ad breaks, it will introduce overhead. It's not going to compress in constant size. It will be linear growth as the number of periods, number of ad breaks increases. That's all. Thank you. Any questions?
Thank you very much. Questions?
Are you running the HLS manifest proxy like on top of media package?
It's more on the client side. Like basically we compress in pattern and then unpack it into flat manifest. Yeah.
How does this compare to using segment template, which already has a constant size manifest?
Yeah, segment template actually is approximate duration. When we have like an AV sync requirement, actually, back in 2017, we have lots of discussion with Quagga. Initially, Elementor used that duration approximation, not a precise, because audio can never be 2 seconds. It's always 2.053, 1.94, something like that. Or for DD Plus, it's 2.048 or 1.986, something like that. So it's not exact 2 seconds. If the player doesn't know the precise segment timeline, it introduces challenges to keep AV in sync. It's a really interesting discussion we had in the past between Elementor and Prime Video. So we prefer to have precise segment timeline, not a segment template approximate duration. You're talking about ad duration, is that right? To have constant duration. It's not really matching this. There's some mismatch between the manifest annotation and the segment duration.
Okay, but that's already covered in the spec, isn't it? Because there's
Yeah.
something about the definition of approximate that says these timestamps in a segment template are approximate, and the player has to know that they're not precise. Over time, the drift is corrected for by this pattern, though, right? Even when you're using segment template, right? So as long as the player knows that it cannot expect them to be perfect, they will be close enough, won't they?
Yeah, that's right. So if the player is able to handle the difference between the approximation of duration versus the segment duration, you can use ad duration, more like annotate the 2.0053, 1.94 second audio segment to be just 2 seconds. It's not precise. The player will have more challenges to keep the AV in sync. The annotated period duration will be a little bit different from the real duration of the segments. Eventually, in Prime Video, we discovered that it's not the right approach for us. Maybe somebody else has a better approach to keep AV in sync.
All right. If there's no other questions, thank you very much again.
Welcome.
And then next up, Saurav. Fantastic.
Good evening, guys. So this talk that I'm going to do is about live origin delivery resiliency maximization. My name is Saurav Ghosh. I'm from Warner Brothers Discovery, and my primary focus is on our video platform, and recently I have been obsessing about quality of experience and how we can improve. As a part of that goal, this is one of the areas that I have been looking at, and I wanted to share some of the tactics that may help anyone else who is looking at those challenges. So without further delay, here's my outline for the talk. So first, I'm going to give you very 10,000 foot level architecture of the live origin, and most of you guys are probably familiar with it. And then I'll talk about something specific in this talk, which is called first mile latency impact. I mean, you guys, we all talk about last mile, which we know. In this particular talk, I'm going to focus on the first mile, and I'll tell you why. And then we'll talk about the mitigation techniques of that could be done to reduce that impact. And finally, I'll have conclusion and Q&A. So if you look at this architecture in general, right? So this is a very high-level architecture, and everybody knows, right? You have a camera source, and then you have some form of contribution encoder ingest process, and here you have the rest of it is basically for the direct-to-consumer streaming. You typically have one primary and maybe another secondary for high availability, and then I'm just saying as an encoder, but internally you have a packaging process, you have just-in-time packaging, and you also have something important called primary live origin. And also in general, you tend to have you have one primary and one secondary for availability, and then they are fronted by some kind of load balancer or an origin shield, and then from that point, you have CDNs, whether you have single or multiple is up to your choice or capacity needs. But the key thing here is that unlike VOD, right, we are talking about time-bound writes of segments and manifest, right? And then we also want to talk about we need the low latency delivery to CDN. So essentially, the live streaming, as we know, is a soft real-time system, right? Every session that is suffering through rebuffering or a failure is a problem, right? I mean, obviously, it's not hard. It's not going to cause death, but death of a session is also important for us, right? So what you want to do is to offer continuous stream availability, right? And anytime, like I said, any rebuffer or failure is a bad client experience. So how do we protect against that? So sometimes we want to have redundancy. If there is a failure, okay, sure. I have a primary origin, you have secondary origin between two different regions. But how do we provide better guarantee on predictability of the first mile? Because there are two things going on here, right? You have encoders that are continuously writing, like I said, and the CDNs that are continuously reading. And why this first mile is important, let me explain. So the way CDN works is that they typically deploy something called request collapsing or request coalescing, right? And that's how they shine in the live case. It essentially says that you got a bunch of requests from clients that are coming in, and they're requesting the same segment or manifest, and they are going to say, okay, you know what? I'm going to queue all these requests together, and I'm going to send one request to the origin, right? So that's what is called the request collapsing and coalescing. And the good thing about that is that it reduces load on the origin, and it provides a fan out where all other clients, if this client keeps requesting the same segment, they will get back from the same request that was made by other clients, right? Now, in general, this works great. The problem with this approach is the fact that if you have a single request that goes to the origin that happens to be slow, your impact also gets magnified. And that is the key problem. Like, the CDNs solve this problem by collapsing as many requests as possible, but they also amplify the impact when there is an issue, and this is particularly true for live origin. So what happens is that in general, I'm going back to a typical service or model where any service that we see, an origin, you can treat it as a service. It has a tail latency pattern, right? So typically, you have if you think about the graph here, there are many ways to describe tail latency. I just chose this one. One of them is on the left side, you got very fast response, and then you have this median that's the top peak at it's acceptable, and then you see a long tail, right, that is going really far out there, and the real-time system like live streaming is going to be bounded by that worst case. So the question is, how do we minimize that long tail? How do you make to the point of P99.99 or even close to P100? As close to the median as possible. Now, let's go deep dive into the origin server, right? So any origin I don't want to treat it as a black box. Let's treat it as a gray box where whenever the CDNs as a client, they're connecting to the origin, they're typically probably going through a load balancer of some kind, right? And then they're fetching it from some set of compute instances. And behind those compute instances, there are storage boxes. Now, they could be like compute and storage coupled together, or they could be separate. I'm not making an assumption on that, because it depends on the architecture. Now, what happens is that if you see there are a number of hops here, and the latency is basically the sum of latency of the serial chain, right? And I know that you can say there is a source of high latency when clients, like in this case CDNs, connecting to the load balancer. There could be network congestion. The peering is not great. There is a problem with the PNI. Or the load balancer is loaded for some reason. There could be a software bug, right? And last but not the least, there could be a storage issue. And if you think about it, right, all these problems could happen, right? It's not necessarily that you can say that it's only a problem that will happen on the storage, or whether it's a hard drive will have more latency on the tail side and flashes less. But you can see that there are problems that can happen at any level here. And now, if you do not have control, if you do have control on the origin, then you can do a lot of things here. But if you do not have control on the origin, then also what can you do? And here is what, think about this way, right? So if you treat this as a system, typically, a lot of times we do microservice-based system, we do something called hedging. And sometimes CDNs can deploy, and this is something you have to ask them sometime, if you own your own CDN, that's even better because you can do this yourself. Essentially instead of a single request, you send multiple requests. And by doing this way, you are actually reducing the chance of hitting the P99 tail latency. Because if you send multiple requests, the chance of all of them hitting P99 is pretty low. And whichever request comes first, you can actually cancel the remaining and you can move forward. I mean, this is a standard pattern for gRPC. The problem with the CDN side is that CDNs are also streamer, right? They are essentially getting segment or manifest. They need to send it as soon as possible. They're not going to hold it that long. And that actually is a problem because it becomes too tricky to say, hey, I want to optimize based on the starting response or time to first byte. That's not necessarily the best optimization because you may get the first byte really quickly, but then the whole delivery becomes really slow. And of course, there are techniques that you can do on the client side, doing multi-CDN and other process. I'm just focusing on the CDN side to demonstrate the limitation the CDNs has in this regard, that they're not a standard client. Because they need not only to ingest this information from the origin, they also have to deliver it back as soon as possible. And majority of the time, they should not wait. Because if they wait for every segment, they hold it and send it, they're going to have an overall higher latency. So these are the only cases where this can be problematic. Otherwise, this will work fine. But however, the note there, you are actually, sorry about that. This thing came up. Oops, sorry. Once again. So the other side effect of this strategy is you see here, like we are actually going against request coalescing that we talked about because by sending multiple requests, we're actually sending more load to the origin than opposed to reducing load. So essentially what it says that we don't want to do too much request coalescing, we rather want to do request expanding. And sometimes CDNs, depending on their architecture, they might actually say, you know what, I'm going to create separate cache keys and you're going to split the cache key so that I can send 2 requests and it will reduce your blast radius. Now, so these are the shortcomings for this case when you're sending parallel requests. The alternative approach is, what if you send sequential requests? So the benefit of the sequential request is that you send one request and you fail really quickly if the response doesn't come fast enough. And then you retry. Now, in this world, you are actually sending less load to the origin. However, you are going to be, and you're also being nice to the origin, so you're not really sending multiple requests, but the side effect of that is how to tune this timeout. I mean, if you have a segment duration of 2 seconds, right? When do you want to time out? If it is, obviously you should not be waiting till 2 seconds expires because then you have to retry again. By that time, there will be rebuffering and probably players are going to, switch rendition to handle it, but you're going to have a rebuffering impact. And the other side effect of that, if you have 2 seconds and if you send it too quickly, right, there could be some other shield or something going on inside the origin that could be doing request coalescing inside itself. Or you're going to overload the origin if you're sending the request too quickly, maybe to deliver within that time. So that becomes a very tricky challenge. But it really depends on your use case and how you can tune it. So typically, you should not be setting it at a level same as the segment duration. It should be much shorter than that so that you have a window for retry. Now, the other side of the story, what I did not talk about, which is that we're looking at on the CDN side, right? But the other technique that we see is that on the encoder side, because encoders, this is a very standard process where one side you are ingesting data, the other side we are sending data through an API, right? And this ingestion process also has a potential issue because encoder is responsible for generating manifest and segment in real time within a deadline. What happens when the writes that you are doing, it's not coming back quickly enough? And you are running out of time because you need to publish the next version of manifest. So in that world, you would like to hedge against two origins. So you basically say, okay, I'm going to send it to one, I'm going to send it to the other, and whichever comes first, I'm ready, I'm going to publish the manifest. And then the tricky thing is that you need to then play on the CDN side to say, oh, how do I fall back and how do I fail over if I get a 404 or some kind? That becomes a tricky situation, and you will have to build those. And you may not think about like, why would I retry for 404? But these are the cases. If you ever want to do this, you should be thinking about retrying on 404 or for failover to the secondary origin. So to summarize this, right? So I talked about why we need the real-time requirements for live origin. I described at a high level about the origin server internals, and I mentioned what you can do to mitigate the first mile fetch latency, and how we can hedge the encoder publish latency. These are the techniques that some of you guys have already been doing, so I expect that. But these are the challenges that we see as we grow and we try to optimize. And shorter you make your segment, more difficult it becomes to meet those deadlines. And as a requirement, we do want to make the segment shorter because we want our customers to be close to the live edge. And so your resiliency does depend on the QA expectation. If you have a longer segment, the chance of this failure goes down, right? These issues. 6 seconds would be pretty, in that case, 6 second segment duration, probably you'll not face these problems. And then, and the resiliency, of course, requires collaboration across multiple components and understanding how it works because, you cannot just say, I have a CDN and I just connect to an origin, it will magically work. You need to understand how origin behaves and how we can set those timeout values to make sure you are delivering it correctly and prevent people from getting those rebuffer spikes. Any question? Yes.
Did somebody have a question?
I'm curious about the serial retry situation. When you have those timeouts, are those timeout for completing the entire segment or just timeout to first byte so that you know something's happening?
Like I was mentioning before, like time to first byte is what we found out is not sufficient. The problem is many times where you get the first byte quickly, but you happen to hit something, I'm not going to say what it is, but it could be a bad drive. It is trickling out the data to you, but it's so slow that if you're just relying on time to first byte, you're going to have an impact. So that's why the CDN clients themselves have to monitor the overall time, not just between bytes. If you have between bytes, let's say 1 second, that means every 1 second you're sending 1 byte, 1 byte, 1 byte, and you're not going to meet your deadline. So you need to look at the total time and cut your losses and try again. And that is the tricky thing.
So to follow up on that, that would seem to imply that you're also not looking at you're also not timing out on the whole thing overall, but you're trying to like keep a long view of like you're predicting when it would complete and then timing out based on that?
Yeah, so you're looking at how long it is taking, and if it is taking more than your configured timeout, even though the segment, like you have still a headroom, you're going to cut your loss and you're going to try again. And typically that works because what happens on the origin side is, like I said, whether it's your NAND flash or hard drive or any other thing, you are going to hit a different server and the behavior will be different, and the chance of hitting the same issue is much less. Usually it is milliseconds. Like these are the P90 cases where it suddenly takes seconds.
Curious, have you considered like a HTTP push to elevate some of the issues? I mean, assuming the CDN supports it, of course.
We have not yet, we have not upgraded our system to that level yet. But you're talking about MOQ? Or?
No. Just HTTP 2 and HTTP 3 support server-side push, where your origin can push your fragments as they're ready to.
No, we haven't done that yet. That's a good point. Thank you.
From an architectural perspective, the techniques you've described on the delivery side, sometimes they are sold by CDNs as origin shields. You know, Fastly, CloudFront, Akamai, they have origin shield products. To you, does that function belongs to the origin rather than the CDNs?
This function belongs to the origin because this is the live workflow. So the origin shield still needs to make a call. I mean, they are doing request collapsing a little bit on the greater level, but the problem here is that the origin is a source of truth, and you're going to have this problem. I mean, CDNs can optimize themselves. CDNs can keep things in the cache and in memory, for example. They don't need to store it on the hard drive for when they're streaming data between different tier distributions, different tier from long tail to edge cache and other places. Unfortunately, yes. I mean, Origin has to provide a non-volatile storage solution. That means we always can look up if something goes wrong, and has to be fast enough.
Any more questions? Yep.
So what is the context of this, technology? Is it under the normal dash or like a chunk CMAF?
No, that's why I treated it as a standard. This is a distributor system problem that I described. It is not dependent on any manifest or segment format. It's just under the assumption that you are publishing manifest at a certain fixed interval, and you are also publishing segments. And I'm describing the latency that you can potentially encounter, how that impacts the downstream players when you have this one fetch that takes too long. So it creates a effect of a butterfly effect where multiple players get impacted, multiple clients get impacted at the same time. And how do we minimize that impact?
Yeah, so my main question behind the scene is when you have chunk CMAF, when the segments become even shorter,
yes.
How will this technology be effective?
That's actually a good point to see, like chunk CMAF when we're doing chunk CMAF 1, but you remember the tail latency, we'll have to, like I said, you have to still deploy some of those techniques because there is a possibility where some chunk segment is taking too long. Yeah, you are trying to reduce the delivery for each chunk. That's what you were saying in real time, but it's not like the size of the payload is a problem. Like actually, if you increase the size, it might be better because you are setting up like if you have a 6-second segment, chance of having this problem is less than even you have a 3-second because you're sending many small bursts. If you're sending a larger byte, it's actually faster to deliver that because you set up a connection and like sending small fragments in a wide area network is much worse than sending a large byte of data. That's the difference.
Actually, that's my main point. So do you guys figure out the sweet point, a 0.5 second is the best with this technology? Or below 0.5 is probably make the CDN traffic very bursty. Do you guys try to do some experiment like that or?
Right now we have the fixed size of the segment, and we would like to make it shorter. Like right now our segment size is like 3 seconds. We're trying to get towards 2 seconds. And when some of these techniques came up when we started shortening from larger 6 seconds where problems were almost non-existent. The moment we started to 3 seconds, we started seeing these problems. Now, when you shorten it further, it's going to go up even further.
Saurav, thank you very much.
All right. Thank you, folks, for being here and for letting me talk once again. I just want to open up by saying it warms my heart to see more conversations about origin. and specifically, like I'm the person who keeps coming to this particular group and talking about origin. I'm just so excited that I am not alone. So today I'm going to talk a little bit about what it takes to operate a 5.9 video streams. And you always want to do better, but 5.9s are really hard. Like, to put things in context, 5.9s is about 26 seconds of downtime a month. And to put this in even deeper context, in a live event, like let's say the World Cup final or something, a 4-hour event, you're talking 140 milliseconds. So I'll get like one of my pet peeves out of the way, which is vendors that show up and say, I got 6 9s, 7 9s, and they're selling you that SLA on top of EC2 with a 4.9 SLA. Like, just be cautious, right? And be very specific on how high this bar really is. And if anybody is giving you a bar higher than this on a single region, they're overselling. They're selling an insurance policy, not an expected outcome. So 5.9s are hard, 140 milliseconds during a live event. And 5.9s require a metrics-driven culture. And you can't, you have to do two things. One is you have to go beyond just saying, are all my vendors giving me 5.9, so I'll have a 5.9 experience, because that does not always work. Because even if all your vendors are giving you the 5.9 experience, you still can get into a situation where your customers aren't seeing it. And the other piece of it is you've got to stop making it black and white. Like 5.9 is not about, is my stream up or down? You got to add a little bit of a dynamic range into what this means. And this is the kind of difference between just talking about 5.9s versus building a metrics-driven culture. So I'll give you an example. When you're thinking about metrics for a live stream, you have to start with the customer backwards. You have to start with the viewer backwards. What actually impacts the viewer? And as we heard from Saurav, they care about glass-to-glass latency. Usually only when they can tell if their neighbors got it faster, but once they can compare it, they suddenly start to care. And streamers, like broadcasters, are constantly trying to reduce that glass-to-glass latency, which increases the demands on downstream dependencies, the CDNs and everything. They also care about high bit rate. Can I get, it's not just about whether the stream is on my TV, but can I actually watch it at the highest possible bit rate? And customers don't know what bit rate they're watching, but what they care about is, can I see the highest possible quality? How many pixels are you losing along the way? How much granularity are you losing along the way? And they may not know that it takes the bit rate, but they do kind of care if they're getting 4K or not, right? That's why they go buy the TVs. And zero buffer rate. So very refreshing to hear Youngjun here, because I've spent a pretty large portion of my life talking to Youngjun about ZBRs. And I've talked about ZBRs at this. I've been obsessed with this particular metric. And once you start with the metrics from the viewer backwards, that's when you start getting into, well, what are the SLOs, the service level objectives that I have for every single underlying service? So in Saurav's talk, you saw the live stream is very, very complex. You've got the camera, the encoder that is sending data to the origin, and then there's the load balancers, and then there's multiple CDNs. There may be a media shield in the middle. There's the customer's Wi-Fi and everything. But on your side, the parts that you do control, having tightly defined SLOs that are grounded with the viewer experience that you're trying to drive goes a long way, because then it allows you to root cause when something is not working as expected. It allows you to root cause quickly what might actually be broken. And going back to ZBR, like why is this metric better than what's my latency or what is the percentage of requests that are getting 500s versus 200 and so forth? Those are table stake metrics. But ZBR is a metric that I guess I hope is still being used. Like at Prime Video, this was a metric that that Amazon just obsessed with, which is what percentage of my viewers were able to watch their entire session without a single buffering event. And that sounds very simple, but there's a lot of underlying details that can go wrong that will impact the buffering rate for the end user. And these types of viewer-facing metrics are way more important than some of the other underlying server-side metrics that are easy to kind of over-index on. And in this particular case, like if you look at customer-facing metrics, low latency, glass-to-glass latency, highest possible bit rate, and zero buffer rates, origination can get in the way. Poor origination can get in the way of all of that. But that's just the root cause. Like and all of the little things that can go wrong on the origin impact that viewer experience. And whether the origin is serving a stale manifest, whether it's being slow, whether it's failing the writes, because guess what? No matter what media shields you put on, you can't cache that which does not exist. So if your writes are slow or if your writes are failing, well, like even request hedging or any of those techniques just aren't gonna help you. And but if you got to start with the viewer, and then you got to get into the root causes, because sometimes some things may be imperfect behind the scenes, but if they're not impacting the viewer experience, who cares? And once you have these metrics, it is really, really important to convert those metrics into good dashboards. That's the difference between my garage. I'm not a very handy person, but I've got like a little toolbox and all the tools are messed up inside of it. But I go to some of my friends' house and it's like when they need a tool, it's exactly organized and they know where to get it. And they spend less time finding it and more time doing the thing, which makes them more handy, by the way. But metrics are just like that, like a dashboard that has the right set of metrics. And they've got to be designed to facilitate root causing. So you start your dashboard designs with what is the customer-facing impact? And what are the underlying dependencies? And each graph on the underlying dependencies has to have a red line for the SLOs for each dependency so that when you come in, you can dive into what is the customer experience, what is the impact on the customer, and which one of these graphs are violating my SLO, so then I can dive deeper into what the problem is. And the goal here is simply to facilitate the fastest possible root cause so you can address the problem, because 140 milliseconds goes by really fast, right? That's this. So when you start talking about humans interpreting the metrics and them being involved, you have to be proactive and you have to be organized with these dashboards. And you have to practice these dashboards. They have to be up in your war rooms. They have to be reviewed regularly, even when you're not having tentpole events, so that your team has the practice on how to read the dashboards, but also is continuously evolving and improving the dashboards that facilitate these root causes. So metrics are important because they help you detect failures. They help you identify leading indicators that a failure is about to happen. And you got to use them to build that culture of relentless excellence. And if you have the right metrics, then it will help you prioritize the right initiatives inside of the company, because maybe reducing latency further doesn't actually impact the customer, but it's a cool problem that you get to work on. But if you have grounded metrics like buffering rates or the average bit rate that your customers are viewing, those are the right set of things to kind of improve on. And then metrics are a dish that is best served fresh. I was debating if I should say hot or cold, because I was like, well, some things are better. Like, I wouldn't want hot ice cream. But they're best served fresh. So in a live event, when you are looking at many, many nines of availability, you can't operate these systems with metrics that are a minute old or 30 seconds old. You gotta have, because you're losing, like, what is it? Like, I think the Super Bowl was, it's like 800 million of revenue being made. Now you divide that by the number of dollars per second, that's a lot of money, right? So if something goes wrong, you want to know about it right away. And you gotta have the customer metrics. What that means is what is happening on iOSs. Let's say there's an iOS player failure due to a truncation by the CDN or whatever it might be. Whatever reason happened doesn't matter at first, but you gotta know that there was a sudden drop-off on your iOS devices. You don't want to wait till you see a tweet. Once in a while, sitting in war rooms, I've been in a lot of war rooms, there are experiences where we hear about a particular type of customer issue because there was a tweet about it. And, and then an exec will read that tweet and will tell us hey, what's going on here? This one customer has this issue. Is this anecdotal, or is there a wide scale pattern? And the amount of time it takes to identify whether it's a wide scale pattern is too long. You can have lots and lots of iOS users or Android users or Roku users be dropping off or going to a different platform. So you want to get these metrics as quickly as possible. And I'll share a quick anecdote. When I worked at Amazon, I used to call it the bull that cannot be named because we weren't supposed to, but you guys know what I'm talking about. But there's a large sporting event that happened in February. I don't work at Amazon anymore, so I guess I can say it. So Fox streamed the Super Bowl this year, and it was done with Tubi. And I thought, watching the way it all panned out, I thought that was a massive success. There was a lot of viewers. There wasn't a lot of complaints. The glass-to-glass latency was incredible. And they broke records. This is, and by the way, I think this is wrong. It says 15.5 million peak audience. This is actually the number of devices, not the audience, right? This is the number of devices. And for events like Super Bowl, there's lots of people watching on a single device as well. So, but 15.5 million peak devices are watching the system. That's at least, you would imagine, 15.5 million people whose viewer experience can be impacted if you have a bug. And you want to find that out really, really quickly. And the way I saw Fox team work, and I thought was very instrumental in their success, was this obsession with client-side metrics that are available as fresh as possible. And they actually ended up building a system to do that. It's called Media Cloud, MCVBS, I think it's an acronym for something. I don't remember what it stands for at the moment, but they built their own metric system that allows them to get metrics as fresh as possible. And that is a very, very hard problem, because when you get tens of millions of devices flooding your system, there's a whole lot of scaling dimensions that come in, even for your observability platform, because you don't want your observability platform to go down. And things get challenging, and they get challenging on different dimensions. There's the CPU and memory, because you have all those metrics. There's the bandwidth from all the metrics and the beacons that are coming in. There's the number of concurrent connections. And these are, the first two are pretty easy. A lot of people, when they're thinking about scaling their web servers and so forth, they'll think hard about. The last two are the ones that usually hit people, in my experience, by surprise. Where it's oh yeah, I tested it. I had a test harness that generated this load. Everything is good to go. And then the real world experience comes, and boom, you get 15.5 million concurrent connections. That's when things start to fall apart, because your server that was acting perfectly fine, when you're throwing 100,000 connections at it, reacts very differently when you get to millions of connections. And the last one is even harder. And that's one that some people even the people who are used to dealing with a number of concurrent connections, because if you're using TLS, the handshake, the number of new connections, new devices that are coming in per second actually can impact your ability to serve the traffic too. But all in all, I think you have to have the proactive engagement in the war room as well. You don't want to wait till an event shows up, till a tweet shows up, to start engaging. And even when you know something is wrong, you got to have your metrics and your dashboards organized, rehearsed, practiced so that you can root cause and you can mitigate the experience for the viewers. And I personally think that the culture of metrics obsession was instrumental in Vox's success as well. And it went beyond just, is my stream up or down? It really over-indexed on what is the end viewer experience. And that's it. Thank you so much for the talk. And I know I'm keeping people from the bar, so I want to make sure I end it right on time. So.
With that said, though, are there questions for Quadra? Questions? Wow.
All right. Oh, here's one.
Can I have one comment,
Okay.
which is, love it, love the observability, love the dashboards and everything. The next level down is, you've got your great dashboard and everything with all the key metrics. Knowing what you're actually going to do, which is, you alluded to that, but that's like the next level down that I like face on a daily basis.
Yeah.
Is like, what are you actually going to do once you've realized, oh crap, there's a problem?
No, it's very true. Like the fun anecdote at Amazon used to be, backups are easy, restores are hard, right? So it's until you have to exercise the outage. And some of them you can't exercise. Like there are outages where I think a couple of years ago, Messenger went down. And people at Meta couldn't actually diagnose the problem because they were using Messenger to talk to each other. So there's all kinds of new behaviors and scenarios that can come up, but there's a lot that you can anticipate and practice.
Where do we validate parking?
Johnny? Was that an observability question?
I couldn't observe the machine.
Could you share the RPS or any other number that you experienced during this event? Like
Yeah,
you
I
said,
mean-
the metric system had a lot of load, so I wanted to know how much it was.
So you can imagine this particular beaconing system beacons every 10 seconds. So each device was beaconing every 10 seconds. Now, there's a lot of natural jitter in, you can't tell the devices to, kind of coordinate and have them perfectly balanced. So with each device, if it was perfectly balanced, you'd get 1.5 million TPS. But they weren't perfectly balanced because just law of large numbers and statistics and so forth. So we saw peaks of around 2 million TPS that were coming in. And that's actually not that bad if you have practiced and rehearsed what each individual unit of your system can do. So we tested individual nodes to be able to handle 2 million connections, 250,000 TPS for this. And the blocking thing for us was the 2.5 or 2 million connections. Like that's so, and then we had a bunch of these EC2 instances, and they were like 16 core boxes, not like metal boxes, that were just there. And for each 2 million connections, we had lots and lots of, or for each 2 million connections, we had an EC2 instance.
So you kind of see that a lot of the streamers are dependent on some unnamed dashboard for their viewer statistics, and like when you think about getting statistics out of a player, right? Like that's kind of a down the line thing is importance, right? It's more important to get a manifest. It's more important to get the next chunk, right? So when you're writing that software, if you're thinking about dashboards, you have to make it just as important. I mean, did they get any feedback about that? About like, hey, this has to happen as well as these other things? Like it's going to maybe affect player experience?
I think there's a lot of canned dashboards that you can buy, and they're really good. They're a really good starting point. But the difference between an organization that has the culture of metrics obsession versus one that just is doing it perfunctory is not taking the dashboards that come out of the box for granted and actually asking the hard questions. And every time there's an anomaly, going in and wondering, well, what chart would have helped me diagnose this issue faster? What chart would have helped me identify that this issue was about to happen? And the teams that are being proactive and asking the questions, like what the dashboard ought to look like, what metrics are missing, where the red line ought to be, in my experience, those tend to be more successful. Of course, everybody's going to have issues at some point, but that's, I think, the key differentiator between obsessing with metrics versus just buying something off the shelf. Jonathan, you had a question.
Yeah. To the earlier question about what do you do when you detect a problem, I just want to point out, I handled the live listings for the Super Bowl, and we had 4 tiers of, if this doesn't work for publishing the listing so that the clients can see it, I had 3 different fallbacks of, we have a script, we have a different job, and we never used any of the fallbacks, but we had to test them and use them, all of them, because if shit hits the fan, we need all of that. And, you know, the folks handling, 15 million people, many running 4K, we ran out of bandwidth, right before half. That was the issue. My colleagues were routing so people were on the right networks because, Fastly was giving so many megabit, more than they had promised. Akamai was giving more than they had promised. CloudFront, all these CDNs were giving all they could and more, and we still ran out. So we were like 5 terabit over what we were allowed to have, but they stretched and did it, but we had to do some routing. So yeah, but the data helped us know what to shift. And so, yeah, there was a few people who had rebuffering right before the half, but that was the worst situation that we had. And that's very lucky, we know that. So it was a fun time. But, having those backup plans is critical.
Yeah, and the exercise part too. Like I watched that with the Fox team too. Like even with the observability system, like you could argue like if the observability, like one bad argument, but it could be that if the observability system is down, who cares? Like it's not like the viewers are impacted, but even for this little thing, they had like simulated the load to make sure it can handle the connections. And it was with Akamai. They enlisted Akamai support to actually conduct a very large-scale test on the observability system.
I do laugh. The game went 15 minutes past the hour, so they let me extend the game for an hour so that it wouldn't stop right before the game ended. So I got to participate, but it was really click one button, and it ran the script, which didn't fail, so we didn't have to use any of the fallbacks. But I like to feel like I participated, because other than that, I had nothing to do. I wasn't routing the traffic, but my colleagues were. So it was a lot of fun.
Awesome. Thanks again. All right, thank you.